In the last section, we created a level that replicated the arcade classic Donkey Kong. We'll make level 2 and level 3 with different mechanics, and lastly, we'll learn how to travel between those levels. This is video 5.1 Raycasting and You. In this video, we're going to take a look at the two trace methods that we're going to utilize, and we'll learn about LineTraceByChannel and LineTraceForObject and the differences between them via an example level project. Let's get started. Alright, let's take a quick second here and talk about another way to detect interaction. Now, this is what's going to be called line tracing or raycasting. That are interchangeable terms throughout multiple 3D software packages. So, first things first, let's just dive in and see what we have right here. You can see we have some cubes. Now, one is moving. Now, what are they doing? Rays fire from the white cubes, and interaction happens with the blue and apparently red cubes. So, let's go ahead and back out of this and dissect what exactly is going on here. So, taking a look at this first white cube and this first static mesh cube. The white cube, as I have appropriately named laser box, if we open this guy up and go into the blueprint editor, let's figure out how it is raycasting to cause the material change from blue to red. So, off of event tick, I'm delaying every 4 seconds, so 4 seconds goes by, and then we come across this node. This is a LineTraceByChannel. So what this allows us to do is to run a ray, or think of it as firing a laser or casting a fishing reel in a certain direction for a certain period of time, from which we can get a vast amount of information about what we have hit or if we have hit, and then execute code. So, in order to do that, we need a start location and an end location. More often than not, that will be your actor's location that you wish to fire from, but you can specify vectors or line traces or raycasts anywhere in the world from any start point to any end point at any time. For this example, we're just going to use get actor location and get forward vector. So what this is doing is the start is my current location and the forward vector is 0. The forward vector, I believe, is on the let's see here. I believe it is, yes, it's on the X. So this vector, if I were to get back into the event graph, this would read as 1, 0, 0. So then we get that forward vector and we can stretch it out into space by multiplying it by a float amount. In this case, we've multiplied it by a value of 500. So that gets added to the original location so we can get our full vector. So this gets our X and Y position, and this gets our vector in forward space to differentiate between the origin and the endpoint. After that, we come to, yes, trace channel, which for the most part we're going to be using visibility. Draw debug type. Now you can have this ray be invisible, you can have it only last for the duration. Currently it is set to draw time of 2 seconds. It can be persistent, or we can just draw for 1 frame. Now, moving on from there, let's talk about this. Normally you don't see this node. Let's go ahead and just create our own real quick here. So I'm going to right click and search for LineTraceByChannel. We'll be getting into the other nodes in a second here. So from this you can go off of out hit and break hit result. And here you have access to blocking hit, initial overlap, the time that has passed, location of your hit, impact point, the precise point, so you don't have to get the location of the collision, you can just get the exact vector point. You can get the normal collision, impact normal, physical material of the actor hit, the actual actor hit. You can reference anything from this. You can reference the component within that actor. So say you have a blueprint, and in this case we do. I can open up this blueprint, and we have a rotating movement component and a color cube static mesh component. So we can access individual components and execute code off of that. You can also get your hit bone name if you're using a skeletal mesh. Carrying an item, you can do that, and you can trace that, and you can trace the start and end points. So from there, let's just go ahead and delete this one. You can see I'm running a multi-gate which allows us to loop back and forth. So every time this laser fires, it is swapping between a set material of I'm red and I'm blue, and displaying the name of the material appropriately. So off the hit component, since that's what we're changing, we're plugging it into the targets. So I don't need to cast to the actor that is being hit right away if I'm for something as simple as this. I can just drag off hit component and we can change pretty much anything. So let's go ahead and compile, and let's hop back into play and see what's up with the cube on the right. Now you see this white cube is firing a ray or a line trace vertically down, yet the cube is spinning, which it's doing that on its own via its own blueprint and the rotating movement component. However, nothing is happening. So let's go ahead and hit escape and figure out why the interaction here is not taking place. So I've called this one appropriately LaserBox.byObject, and you're about to see why. So it is the exact same code for our BP laser box. However, there's something different. This is using what's called a line trace for objects, and this requires an object type input. This comes from an array, and we can classify which object types we wish the array to interact with. Currently it's set to pawn, so it's only going to interact with pawns. In order to interact with a cube, or specifically the rotating actor, we can change this to world dynamic. We can even add more. We can add world static and so on and so forth. If we wish to get rid of one, we can just right click and remove array element pin. So the code is the same. Instead of getting the forward vector, we are getting the up vector and multiplying by a value of -500. So forward vector was 1, 0, 0. Up vector is, of course, 0, 0, 1. So we are multiplying -500 units south or down. And then, so after the delay, we line trace for objects for a draw time of 2 seconds. For duration, we access the break hit result, and we use our multi-gate to loop back and forth between setting the material. So let's go ahead and see if this works now that we have changed our array to world dynamic. Go ahead and hit play, and let's watch and see. And there we go. Now the material is changing because now it is interacting with a dynamic or a world dynamic object. And you can see that this is happening because if you see this line from the ray through the box has turned green, that signifies that the ray has interacted with something that is compatible with the line trace. So you can see here we have, actually the distance is a little too long on that one. An easier way would be to change it back here and compile, and then let's just go ahead and play again. The ray will continue to just be red. It won't detect the object. You see? There you go. So since nothing has happened, it doesn't know what to collide with. And if we were to stand here, since we are in fact a pawn, the ray turns green. So easy as that. So there are many, many uses for this, and it doesn't stop at changing materials and things like that. We can go crazy and just spawn particles. We can destroy actors. We can spawn actors. Any code that you wish. We can use event dispatchers. It's all at our fingertips. What was I looking for here? We are looking for a new location for this particle emitter. That's right. I'm going to use a special type of break hit result. Let's use the impact point. So the particle only spawns exactly where the ray hits. So let's go ahead and compile, and let's go and play with our new experiment. Now, I'm going to erase, and hopefully we can see this. That's right, we didn't change that. I'm gonna go ahead and move this wall so we have easier access to get up here and see. But we forgot to change the array back to world dynamic. There we go. Gonna run up the stairs and check out the ceiling of the box there. There you go. So it's spawning exactly where the ray hits. And that's pretty neat. Okay, that pretty much covers those two nodes. Those will mostly be the extent of what we're going to use in the next video. So let's go ahead and play around with this a little bit more. I'll see you in the next video where we'll utilize this to enhance our game experience. Let's summarize what we've learned. Alright, now that we have learned about line tracing and how to utilize it, we can implement this into our existing game level. So, let's do that in the next video. See you there.